And good morning and welcome to the National Tropical Weather Conference live stream. This morning we have Kodi Berry with us. All of this is a team effort with Bill Reed and Tim Smith helping me out here this morning. And now here is Tim Smith.
To the National Tropical Weather Conference Live. We appreciate you being with us this morning. This is the virtual version of the National Tropical Weather Conference, which has been going on South Padre Island, Texas for many years now. And South Padre Island Convention and Visitors Bureau is one of our sponsors, even though we're not there in person, and we appreciate all they do to make this possible. USAA, also one of our sponsors this morning. We couldn't do it without them. And of course, Ply Locks, folks that make these little guys right here. You clip it on the plywood, slide it into your windows when a hurricane's threatening. It's one way to keep yourself safe during a storm. In addition to Kodi Berry this morning, of course, we have Mr. Bill Reed with us. This is the second time this season that one of us has had to deal with a landfalling hurricane. Of course, it was here in deep South Texas with Hannah a few weeks ago, and now it's the southeast Texas, southwest Louisiana coast with Hurricane Laura, and not far from the center line is our good friend Bill Reed. Bill, how's it going where you are this morning?
Well, it's going really well, Tim. Thanks for the intro on that. Speaking of ply locks, my neighbor was putting his boards up yesterday, and he in fact was using the ply locks clips to rapidly get the windows covered in his area. The biggest threat is going to be east of us. We'll get a glancing blow of it. I'm going to show a few slides this morning on the storm. Let's see if I can get it to work. There we go. All right. Thought I'd show you to get a perspective of how large Laura has become. This is the more global shot of GO 16. You can see how big it is compared to any other weather system in the northern western hemisphere this morning. We'll talk at length about our big storm. There's a couple of areas in the Eastern Pacific that they're looking at. Kind of curious what's going to happen with this cluster of thunderstorms in the Southwest Caribbean, but not being outlooked at this time. A couple of waves crossing, one coming off Africa and over here. And none of the models get too excited about these. One coming off in about a week. Both the European and GFS amplify it. It's way too far out to even consider what the tracks might be. The latest forecast on Laura is an update from the previous one with one important exception. It's still undergoing rapid intensification. It's dropped 27 millibars in the last 12 hours, and it's now forecast to be a strong Category 4 with the forecast wind speed at landfall of around 125 knots. That's going to be catastrophic on this track to all of southwest Louisiana and some portions of southeast Texas, and storm surge will be all the way over to the mouth of the Mississippi. This is the inundation graphic that's produced mainly to show how far inland the storm surge of a Category 4 will penetrate in this area up the Sabine River, Calcasieu River, and others here, streams here. Cameron and Calcasieu parishes are totally inundated in a storm of this magnitude, and water will get all the way up into Lake Charles on this if it follows this track and size and strength. So that's going to be the big show, is what happens with the storm surge. Rainfall, normally we're talking 20 inches in some of these big monsters that come in here, but it's moving fairly quick, and I agree with the forecast of 10 to 15 core right at the coast, and 5 to 10 being more common along the track. It'll even be producing rain in the mid-Atlantic as it exits as either a depression or a remnant low coming across there. And there's some chatter it might even redevelop in the Atlantic. So with that, if I can get my screen to behave here. Well, there's the radar. It's now in radar range from Lake Charles. And you can see the outer rain bands approaching the coast in a well-defined eye, even out at 250 miles in there. Okay, I don't know why I'm not able to get back here to kill the screen. There we go. Okay, today's speaker is Kodi Berry. She is a program leader for forecasting a continuum of environmental threats, otherwise known as FACETS, at the National Severe Storms Laboratory, NSSL. Her primary area of research includes how broadcast meteorologists use and communicate probabilistic information in a mock television studio environment. Before joining NSSL, Kodi was a Sea Grant liaison at NSSL and the Cooperative Institute for Mesoscale Meteorological Studies at the University of Oklahoma. She also managed and coordinated across all experiments that took place in the NOAA's hazardous weather test bed. Kodi completed her undergraduate education at the University of Nebraska-Lincoln and graduate education at the University of Oklahoma. So with that, Kodi, it's all yours. Need to unmute.
Sorry about that. So thank you for the introduction. Yes, I'm the FACETS program lead at the National Severe Storms Lab. So despite everything exciting going on with Laura, I'm going to take us a little bit into some severe weather land, but it does have future applications to the tropical world. So let me go ahead and get my screen shared. Can you guys see that?
Yep.
Yes, that's perfect.
Okay. All right. So, as Bill mentioned, FACETS is forecasting a continuum of environmental threats. What that means is it's essentially a proposed modernization of NOAA's entire forecast and warning process. And because it's the entire process from beginning to end, it requires an integration of both social, behavioral, and economic sciences as with the physical sciences, which is really exciting, I think. Really, the FACETS goal is to produce a continuous flow of high-resolution probabilistic hazard information. So we're going to start adding on to the acronyms. Here's FEE, extending from days before to within minutes of an event. And this is for all environmental hazards. So this graphic sort of displays the current product-centric paradigm that we're in with severe weather. We've got outlooks starting days 4 through 8, all the way through to day 1, and then we kind of sit around and wait for the watch. And in that gap period, there's a lot of stuff going on in NWS chat between the National Weather Service, broadcasters, and emergency managers. And then after that watch, there's another gap until warnings start being issued. So that, right now our main gap filler is NWS chat. So FACETS the goal is to sort of fill those gaps and focus more on providing data than specific products. And essentially, FACETS will enable better individual decision-making since it's incorporating those social and behavioral sciences and focusing on the entire forecast process, provide more consistent communication and decision support services, which is a huge emphasis in the National Weather Service, and also provide meaningful quantification of hazard probabilities. Now, some of you may have heard a little bit about FACETS. So this is really sort of an overview for those that have heard of it before, to sort of dispel some early assumptions that were made, and through the research and development process, we have sort of determined really don't work. One of the early assumptions of FACETS was that for a single hazard, we would be able to create a single grid of threat probabilities. There was a grant called Probability of What? And a lot of research went into figuring out that just isn't possible mathematically. When you try to get the small scale threat onto the larger scale threat grid or vice versa, it ends up washing out one of them. And so this really led to us realizing that one of the big goals of FACETS is going to have to be creating what we call reference classes for probabilistic products across various time and space scales that everyone can understand. And then the second early FACETS assumption was that warnings would be able to fall out at some sort of threshold that was identified by social and behavioral sciences. And within NOAA's hazardous weather testbed, we tested ways of doing this, from allowing the forecaster to specify what he or she felt was the warning threshold to 0%, anything greater than 0 being a warning. And then we've also recently started testing a time-based warning, not focusing it on the probability itself, but those more standard Weather Service definitions of 30 minutes, 45 minutes for tornado and severe thunderstorm. So there are some hazards where, like with tropical and the storm surge warning, they've done a really good job of that working for falling out at a threshold, but for things that are rapidly updating and on much shorter timescales, like a severe thunderstorm or a tornado, that sort of probability falling out warning, we have found doesn't work. So essentially, FACETS is a framework, and we're focusing on moving away from that product-centric paradigm. We're not doing away with any of those current products, but really just focusing on how we can provide that probabilistic information across all of the time and space scales leading up to an event. So next, I'm going to take you through the individual facets of FACETS. And the first one is probabilistic hazard information, or PHI, and these are essentially grid-based probabilities. And as we know very well in tropical, that these already exist in Weather Service product suites. The tropical storm force wind and hurricane force wind probabilities are probably the best example, and it have been sort of a motivation for what we've done in the severe weather realm. And these essentially serve as the foundation for decision support services. They also can lead to things like the storm surge hazard map and earliest reasonable arrival time of tropical storm force winds. Those are all products that look deterministic in nature, but they're actually built on probabilities. Facet 2 is observations and guidance. This is what forecasters use to make decisions, whether it be radar data, satellite data, model output, observations. It's what they use to make their decisions. Facet 3 is focused on the forecaster, the person that's making that forecast and warning decision. They are as essential as ever to the entire forecast and warning process. It includes their knowledge base, skills, abilities, how these new technologies and tools will affect their workload. And essentially this new paradigm is going to result in a whole bunch of new training that they're going to have to go through. Facet 4 is threat grid tools. This is what forecasters use to create the probabilistic hazard information, both hardware and software. From a software perspective, what is really pushing all of these capabilities into future operations is hazard services, which is being developed at the Global Systems Laboratory in Boulder, Colorado. Facet 5, usable data. This is what the end users see and hear. And by end users, I mean our broadcast meteorologists, emergency managers, as well as the public. This is looking at graphical data, text data, anything that could possibly be auditory. And this is where social and behavioral sciences are really key. Facet 6 is effective response, what the end users do with the information that they've received. And this is really that interface between the physical and social sciences. I feel like it's the most important facet, because if everything before that is perfect and the response is not, then we still have so much more work to do. This is really where the social and behavioral science research ultimately pays off. And then facet 7 is verification. And this is evaluating the entire system's effectiveness. So we're not just measuring forecast skill, but those human responses to the information as well. So what has been done with facets in NOAA's hazardous weather test bed? So for those that aren't familiar, there are actually 11 test beds and proving grounds across NOAA. They typically align with a hazard area. So the hazardous weather test bed is a joint project of the Storm Prediction Center, the Norman Weather Forecast Office, and the National Severe Storms Laboratory. And as it's a conceptual framework as well as a physical space to allow researchers and those in operations to collaborate and test and evaluate those emerging tools and technologies and science for weather service operations. NOAA's hazardous weather testbed has 3 focus areas. There is an experimental forecast program, which focuses on the prediction of hazardous weather events from a few hours to a week in advance. And the largest activity done within the experimental forecast program is the spring forecasting experiment. We also are in partnership with the satellite proving grounds. And so a lot of GOES-R and JPSS satellite products have been evaluated within the physical space of the hazardous weather testbed. And then there's an experimental warning program that focuses on detection and prediction of hazardous weather events up to several hours in advance. And that's what I'm primarily going to talk about. A typical hazardous weather testbed experiment lasts 3 to 5 weeks. We bring in 2 to 4 weather service forecasters each week to Norman, Oklahoma. They come Sunday, leave Friday. We put forecasters, researchers, and academics side by side, and this really makes it easier for researchers to understand operational challenges by seeing operational forecasters use their products and tools and provide real-time feedback. There are 2 primary types of experiments. There isn't a whole lot different between them. There's real-time and archive simulations. Both allow us to emulate any weather forecast office in the United States. All operational data sets are available for both, and experimental products are available through special menus that our staff help incorporate through AWIPS. The biggest differences are that in a real-time experiment, you can log into any other office's NWS chat room and get live reports. In archive simulations, researchers have to archive all of those and feed them in themselves. During real-time experiments, we can take advantage of live TV news station streaming, but archive simulations allow for things like data denial and more controlled experiments. So by data denial, I mean you split your forecasters into 2 different groups. One group is getting one set of data, the other group is not getting that data, and then they can compare directly whether or not the addition of that data affects perhaps the warning lead time, as an example. So it just allows for more controlled experiments. We receive feedback from participants in a variety of manners. Some experiments take use of live blogging, where forecasters provide their pre-warning thoughts and also take screenshots and blog that out as they're participating. Throughout the week, at the end of each day and the end of each week, there's dedicated face-to-face time between the forecasters and the developers to discuss products and problems they may have encountered. And then we also remove the social pressure and have people fill out surveys to provide feedback on the strengths and weaknesses of products. The project that I've been most involved with has been the feed prototype experiment. This is where National Weather Service forecasters use automated guidance and a feed prototype web tool that mimics the Hazard Services platform to produce probabilistic nowcasts or FEE for tornado, severe wind and hail, and lightning. And the benefit of this feed prototype web tool is that it allows for quick successes and failures through evaluation. And so changes can be made like on the fly during the middle of an experiment, whereas Hazard Services FEE is using Hazard Services, the next generation warning tool for the Weather Service. So to make these development changes within AWIPS is a lot more time consuming. So we test and evaluate things within the feed prototype, and then those successes get passed on to Hazard Services FEE. And that's the software that will make the FEE concept operational within the Weather Service. Things that we've done with both of these FEE, Hazard Services, and prototype experiments, we have tested with just forecasters. We've tested with forecasters and emergency managers, and we've also tested with a full integrated warning team of forecasters, emergency managers, and broadcast meteorologists. Concepts that we've tested, we've tried giving them just fee and no warnings. That did not work for emergency managers, so that was quickly scrapped. As I mentioned earlier, we've tried warnings at probabilistic threshold values, whether it was forecaster specified or 0%. Neither were useful to the end users because they felt like that their threshold varied depending on, for example, what the SPC outlook was for that day. We've tried the rapidly updating fee with just the regular legacy polygon warnings. That was difficult to communicate because you had this updating tornado probability and this static warning, and at times the fee plume was sort of leaving that warning polygon box. So that created some communication difficulty for broadcasters in particular. And then we've also tested what's called threats in motion, which is that time-based warning, but it is also rapidly updating and it moves with the storm instead of being that static polygon. So as part of this large fee experiment, the way we've incorporated emergency managers is they are receiving in real time those probabilistic forecasts and nowcasts or fee that the forecasters are creating in a different room. And researchers assign participants to jurisdictions for each case that are in line with their actual jobs. So we've had city, county, state, hospital, and university emergency managers. I think we've even had some federal regional managers. So we just try to tailor each case to what their normal job is. And then they essentially make decisions using weather service warnings and that probabilistic information. And then my sort of baby experiment is the fee broadcaster experiment, where in another room, broadcasters are receiving those probabilistic forecasts. And we assign programming schedules and DMAs for each case, and then they make coverage decisions, whether that be posting to social media, running a crawl, doing a short cut-in, or going wall-to-wall in a simulated television environment. And so here are some pictures of just what each of those different rooms look like. On the left-hand side, that's the actual hazardous weather test bed. So those are all of the weather service forecasters that are issuing fee and warnings. And then in the center, we have our KFI TV studio, which is the Oklahoma Weather Lab, owned by the School of Meteorology. And then on the right-hand side, we have the emergency managers working their various jurisdictions. So some people ask why broadcast meteorologists, and I really love this survey. Every year there is OU's Center for Risk and Crisis Management is conducting a longitudinal survey, longitudinal as in year after year after year. They're doing this nationwide survey where they're polling a nationally representative population about things like, how did you learn about the tornado warning? And consistently, even though there has been a little bit of a drop between 2019 and 2020, television is the #1 source that our public is receiving tornado warnings. And that, to me, that just makes broadcasters as human subjects of research one of the most important subjects in that entire warning communication process. And I believe these same folks are starting a survey about hurricanes. So I can't wait to see what they can glean about hurricanes, and they would actually probably be really great presenters in the future. But with our broadcasters, our major research objectives are: how do broadcasters make decisions with fee? How do they communicate the probabilities verbally, visually? Do they prefer different platforms for different hazards? Because we give them, we typically put one broadcaster on the wall and one at a social media desk. Other questions: how often should probabilistic information update? just as a blanket question, everyone wants it as quick as they can get it. But the bigger question is, what can each individual news station handle in terms of station bandwidth and how frequently they can receive it? And then even on the Weather Service side, what can their infrastructure handle in terms of distributing? How frequently can they distribute that information? The big question, should the probabilistic plumes be tied to the warning polygon? And then how do broadcasters communicate both probabilities and warnings at the same time? So for our KFTV setup, we have a chroma key wall. We use an experimental version of the enhanced data display to essentially try to simulate broadcast software, since we don't have a Baron or a WSI. And then we also have GR2 analysts for radar interrogation. We use NWS chat or Slack for that, to mimic that NWS chat communication between the integrated warning team. We create station agnostic television programming schedules, which does allow us to cherry pick some of those more difficult shows to cut into, like Judge Judy, wireless lapel mics, camera and lighting, and then a protected Twitter account that no one can see, but they can actually send tweets out in. And then we asked them to focus on 6 types of coverage. These were actually determined, the first year we did this experiment, it was very exploratory, and these were the 6 coverage types that emerged from that year and then remained constant over time. So crawling messages, short cut-ins, whether that be just a cut-in over programming, taking over a station identification, commercial breaks, national or local, taking over the weathercast, or just covering the weathercast during the local news, wall-to-wall coverage, online streaming, for example, on a station website or Facebook Live, and then posting on Twitter. Things that we've tested. One early tested concept was color schemes. The initial rollout of the enhanced data display just had every hazard, whether it was lightning, tornado, or severe, was as a rainbow plume, and then the little circle was what actually depicted the hazard. I think because of its similarity to radar data, broadcasters typically prefer that rainbow scheme at the beginning of the week. But I think we're at like 100% that by the end of the week, they gradually shift to preferring the monotonic color schemes due to cases with overlapping hazards. And they felt that that made it easier to communicate. If they were focused on severe and then all of a sudden that red just popped in their faces, it made the communication a lot easier, and it made it easier for them to sort of triage the data. Broadcasters have said that the fee allows them to make more informed coverage decisions. We had one participant that when we were working with the traditional legacy polygon warnings, how much earlier they went on air with fee than had they waited for the warning. And so they were able to go on air up to 20 minutes before the tornado warning was issued based on the probability trends and this forecaster discussion text that they had access to. They were also able to return to programming earlier based on decreasing probability trends and being able to read that forecaster discussion. And so ultimately, it made them more confident in their coverage decisions with fee. In terms of communicating threats, broadcasters like that it gives them an opportunity to tell some people, you in these lighter colors have a chance to get to a safe place, especially if you're in a mobile home, as opposed to the current warning communication strategy, which is if you're in the warning, you need to seek shelter now. They also liked that it helped that the fee plume itself sort of takes care of storm motion and they don't have to plot it themselves. And because when they plot it themselves, they could be off by a few degrees. And then in terms of communicating threats, they liked that there was one object and one plume instead of what we sometimes get with overlapping warnings of the same type of different types. It just simplified the visual display of the hazards. The biggest thing we're still grappling with is how to define the warning. That's actually a social science project that's going on right now. What is a warning? What do forecasters feel a warning is? Does it just boil down to hazard probability, or are there social factors such as local vulnerabilities that impact if and when they warn? Some of the feedback that we've gotten about polygons and plumes and viewing them together is that together they can be too much. It can be difficult to communicate if there's a higher probability without a warning. But some feel that it's not a problem if they do their job correctly and communicate it. So what does this ultimately have to do with tropical? Other NOAA testbeds are seeing the importance of incorporating core partners into the research and development process. Hazardous weather testbed staff, including myself, participated in a June workshop that included Weather Service and the Office of Oceanic and Atmospheric Research, which is the NOAA line office that all of the research labs fall in, to work towards incorporating core partners in a hurricane testbed. And if anyone is interested in keeping up with what's going on with KFTV, we actually do have a Twitter account for our fictitious news station. And that is all I have.
Wow, that's a lot of good material there. I guess I could start it off with a couple of questions. It came to mind. To me, that the time-based warnings seem to make a lot of sense, both on the front end of being timely on the increasing risk, but also in clearing areas no longer at risk. I've always had a problem with having to explain to people, well, there's warnings still out, but you're not really at risk anymore. And what have you found is a manageable update frequency, say, for tornado warnings under this concept?
So we are actually scheduled to have a workshop on that very thing. It is a dissemination workshop focused specifically on threats in motion to cover everyone that's involved, from forecast offices to NOAA Weather Radio, NOAA Port, your Barons and WSIs, as well as emergency management. What can the entire system manage? That is sort of our biggest unanswered question. And so hopefully we will find out soon through that workshop process what is possible. We've tested as frequent as 1 minute, but is that feasible in terms of bandwidth and technology? Probably not. So that's what we are hoping to figure out within the next year.
Okay, interesting. How accurate are these the PHI plume products? Have you had a chance to do verification on the data?
So they are a work in progress right now. The way they're being created right now in the test bed, forecasters have automated guidance, things like props of year, to help them shape it. But really the biggest uncertainty is the time trend, like what it's going to do over the next hour. And so we are working towards in sort of a blended approach with things like warn on forecast. So we're working to blend those two, to starting that sort of collaboration together.
Okay, yeah, it's when I was at the HurricaneCenter, that was always a challenge to think through, is how are we going to verify the probabilistic forecast information? And I think we figured out a way on the storm surge, not so sure we've got it figured out yet for the wind speeds. This question crossed my desk here. Has the dealing with COVID made it difficult to run the test bed this year? I would think.
So it has. It really has. We had an experiment that was set to start, I think, March 16th. And before it started, I think the Thursday or Friday before it started, the facility is on the University of Oklahoma campus, and the University of Oklahoma shut down all in-person groups larger than a certain number. And so we are in this weird space of following university guidelines as well as NOAA guidelines. And so that experiment was postponed the spring forecasting experiment, they were able to move forward with parts of it and do that virtually. We are starting to delve into AWIPS on the cloud to start having some virtual spring experiments, possibly one this winter. And then that one that was supposed to start in March is actually starting next week, I think. Yes, next week. And they're going to do that all virtually. And they only had one sort of warning exercise, and a lot of it was focus group based. So they just removed the warning exercise and are focusing on just being able to interact with the forecasters. But Global Systems Lab did a forecaster assessment test of hazard services back in June through AWIPS in the cloud, and it went really well. And so they debriefed us and the operations proving ground on how that went. And so we're moving forward with that virtual aspect. They said it was really great because they were able to have forecasters participate from as far away as Alaska. So in the long run, it's actually cheaper than paying for forecaster travel. So I imagine that moving forward, we'll probably, even if it's not necessary, we could then have sort of a blended approach to being able to have some virtual participants as well as in person once it's safe to do so.
That's interesting. We've heard that on several of endeavors people are involved in, how there's a plus side to this hard thing, is we're learning how to do things in a totally different way. Mm-hmm. Tim, why don't you chime in, and I'm sure you got some interesting questions from the broadcaster's perspective.
Yeah, absolutely. Great presentation, Kodi. Thank you. I think this seems like it's working toward a unified message going out as well, much like we see the cone with the hurricane forecast. It's a similar situation. I know just within our shop, we have 8 meteorologists, all with varying degrees of severe weather experience. And when the polygon comes out, everybody, okay, now where is it? Where's the tornado? Which part of this polygon is it? And with that fee plume, I think that really, gives everybody that unified message, and not just in my shop, but across the market.
Yeah, it's the plume itself is typically smaller than the warning polygon. The sort of idealized flow would be that you would see very low probabilities building, and then so then you can anticipate that warning, which is what that one participant that timed themselves was able to do. And I loved that they did that, because now I can use it in presentations, because I would have never thought to do that as a researcher. But
yeah, you're always trying to anticipate, what's going to happen next, and that really gives you an opportunity to do that. You're not guessing, and everybody's guessing differently, because there is some scientific guessing involved. So it brings kind of a unified message together. They've been working with the various weather graphics companies, WSI, Barron's, and how to incorporate this into their systems.
We have not yet. The one area that they have been engaged is with threats in motion, the moving and rapidly updating warning, because that is sort of the first that will probably transition to operations. We're hoping within 5 years. There's actually 2 different research focuses for that. One is looking at what can be done with existing policy and existing technology to, cut off the back end of warnings so people are in the clear faster, and extending area, extending time, very in the weeds details like that. And then, what can the future communication system as a whole handle? And they have said, if you give us about 9 months, then before you roll it out, then we should be able to be prepared for it. We haven't, in terms of the fee plumes yet.
That's good. That's a big part of it. Do you think that your graph showed that, broadcast meteorologists is the way that a majority of people still get their warnings. But with the advent of social media, and I know in our local National Weather Service Brownsville office, they're very active on Facebook and Twitter. Do you think that what we do in broadcast is going to eventually be done in the Weather Service offices, because you don't necessarily need the broadcaster as much anymore as you used to? You've got your own avenue to the public. You've got the conduit.
I still think that the broadcaster plays an important role in that communication process, explaining what's going on, being able to provide more up to the minute information when they're in that wall-to-wall coverage setting. In this digital age of Netflix and Hulu and all of that stuff, I still turn on we've got an antenna in the attic. I still turn on the local TV when it's a severe weather day. I think there's that sort of local trust of, you think that person.
Right. Well, that's good to hear. We like to hear that on behalf of everybody watching. Thank you. We appreciate it. But it's true. We look at the ratings, during Hurricane Hannah down here, they quintupled during the hurricane.
Yeah.
And for all stations, not just ours, but for all stations, they just jumped dramatically because people want that local information. So, and the better we can convey that, the better. And with that fee plume, I think that's I like it. From my perspective. That's all I have from here. Bill, do you have anything more on your end?
No, just a comment. I mean, it's very gratifying to see that we keep advancing on that from back when I was starting out, banging out a message on a teletype ribbon, and then not really having the wherewithal or time to update it very much for a whole county. With limited ways of disseminating to even you people at the TV station there. You didn't get a graphic at the time either from it. The Polygon was an improvement on that, and then all the graphics we can now interchange with each other, and I think this is the next step forward to making it more concise, really get down to the fact that when we put a warning out, we really mean you and not somebody within you. So yeah, Kodi, thank you so much. That was fascinating.
You're welcome.
Kodi, we appreciate it. Bill, you say that from the Weather Service perspective of putting that out. And I know when we had the teletype in the newsroom, we would watch for that header that would have the county code, which was a number, and the type of warning and the expiration time. And as soon as we'd see that first line print out, we'd go on the air with that before any of the text came out.
Yeah, it was coming at you at a mighty 25 words per minute.
Exactly. So times have changed. Great presentation, Kodi, and I agree with Bill. It's good to see where we're headed, and we just continue to move in the right direction, and that's keep people safe ultimately. So thank you for that. Appreciate it. Bill, thank you for the update on the hurricane. I know you've probably got plenty of work to do today to stay safe. Glad your windows are covered and you're ready. So we wish you the best, Bill.
Yep, I'm thinking if it behaves itself on the track, 30 gusts to 40, maybe 40 gusts to 50 out where Jonathan lives close to the water, we can handle that.
I hope the cedar fence survives and everything in the yard stays put. Kodi, you'll get your very own National Tropical Weather Conference Live mask in the mail shortly. We appreciate you being here today. Thank you so much for that. Alex, we've got some more programs coming up next week and beyond, don't we?
Oh, yeah, Tim, we really do. We've got some really good ones coming up next week. We have Eric Salda with The Wall of Wind. Boy, that is going to be one exciting program, so we hope you're there. Then coming up on September the 8th, that will be the anniversary of the 1900 Galveston hurricane. We've got the folks there from Galveston, Lou Fincher. We've got Jody Skidley and also Stan Blazek and Chris Lancy. All will be talking about that 1900 storm. Thank you so much for being with us today. We appreciate you being here. Don't forget our sponsors are USAA, South Padre Island Convention and Tourist Bureau, and Plylux Hurricane Clips. Join us again next week at the same time.